And even so actually, I was not even so many folks raise their hand. How many of you have worked with Indian security or are trying to work on security for Indian workers? There's a few hands. So hopefully by the end of today's talk, we'll be able to have everyone raise their hands because I'm super excited to work on this topic. And I'll also explain the reason why. So as my title suggests, we're going to talk about how you can improve security for LLM applications for cloud LLM. Because as you know that most companies today are either anything products like AI or fraud or these open source models. But one of the biggest issues that we have is that you never know what your companies are going to do with your data. So a lot of companies are trying to move towards an on-prem solution, which means that self-hosting these models. But that does come with a lot of risks. And also the issue is that most of the SI teams today are not very equipped to understand what are the security concerns for AI applications and AI models. They have traditionally been working with simple microservices architectures. So we'll be exploring some of those areas and how we are mitigating those with the help of cloud native AI capabilities. So very quick introduction, I'm Shivay. I'm a CNCF bachelor and I also work as a systems engineer for Couchbase. So Couchbase is a NoSQL database platform. And like many other database companies, we are equipped in very quickly to also support AI and workloads with vector databases and RAG. And I'm also a contributor to the project called cTENcf. We'll have a talk by Ram around this particular project. And I've also been contributing a lot Qflow. So this year I'm also a full support mentor for Qflow for adding Postgres for Qflow packages. So as I mentioned, that I've pretty much been involved with more cloud native ML service for the last 4 to 5 years. If you have any questions regarding the CNCF landscape for AI, please make sure to connect me. So today's agenda, we have a quick overview of how LLMs are deployed today, and we'll also kind of cover how we have moved away from, or we have moved moving away from AI gateways to API gateways to AI gateways, and what are some of the security concerns that you will see in production when you are deploying LLMs, and how you can mitigate. So this is a very simple architectural view of internally what our platform within Couchbase that we're building. And the reason I just wanted to quickly show to you is that a lot of the different open source technologies that I'll be talking through is something that can be applied in production with our platform. So the entire idea was that we wanted to have the capability of being able to self-host large language models and also many models and making it sit right next to your database so that A, you have secure access to your data and B, you also have very less latency. And the way that we were able to accomplish this by building an in-house AI gateway and building an entire platform where you can self-host your models with the help of PLLM and technologies built on top of container technologies where you can revise within our container runtime systems to make sure that your LLM is in the same network as your database to ensure most highest amount of security possible. While at the same time, we leverage an AI gateway, which I'll describe a bit more further, to add even more authentication and authorization fine-tuning for AI workloads so that we can absolutely ensure that there is no security risk involved with your system. So we basically call this Kapila AI services. And if anyone has any questions, if you're trying to build a certain kind of architecture, I'll be more than happy to kind of cover that. But let's talk about LLMs, guys. So of course we had a few talks kind of covering what AI is, but LLMs are kind of the latest and greatest model architectures, mainly based on the transformers architectures that we already had in time. Now, if you look at the biggest security aspect, we have already seen some major security issues come up with LLMs. So some of these include a huge study around the NVIDIA container toolkit, which affected a lot of different devices. And again, common CVs that we saw, which you see for traditional cloud and workloads, we are now seeing a lot of reports where people have been able to use concepts like prompt injection to be able to get access to private data by just being able to pool the entire LLM by providing certain set of prompts and prompt templates that made the LLM get tricked that this user is actually a good user and they were able to pull valuable or sensitive information that a lot of these organizations were putting. Right? So these are the things that we need to be aware of. And another aspect is also that today so many people are using code generation tools. So sometimes you might not realize that if there is a malicious factor in one of these particular LLMs, it could generate some code that could basically allow it to have some sort of injection of some malicious activities without you ever even knowing. So that's why like most of these platforms like PyPy or NPM, where you have a lot of your code models or libraries for code, they today are implementing more robust practices to ensure that if there is code being generated from AI, you're also ensuring proper security practices for that, so that there is no unknown variables involved when you're dealing with these type of applications. So those are some of the security concerns that we have recently run into with LLM. Now, if you look at the traditional ways of deploying business, I think this is important to cover in this particular slide to understand the core crux of what people are doing today. So you have a lot of self-hosted versus deployment options where you will use things like GitOps or Hyperface. You can also always containerize them with Docker or GitOps, or you can also serve them with the help of Kubeflow. And then you have the cloud APIs that you can always use, or you can also often for a hybrid model where for some workloads you use self-hosted models, whereas for larger, more powerful workloads, you go for a cloud option. Now, this is traditionally what we see as an architecture for most companies that we are applying. So we are using LLM workloads. You start with the client and your AI request is being sent to a load balancer and then it will be sent to an API gateway. And from there, it will go to the LLM service like OpenAI. So basically, your API gateway will be responsible for routing your requests from the user to the LLM service and it will go to the model service provider and it will give you a response. But this architecture in the context of LLMs is highly, highly, it's very vulnerable to different types of attacks and every single day. So whether it's on the client side, that as soon as the request is being sent to your load balancer, there might be malicious actors in place where they might be able to use things like prompt injection, or they might be able to get into that API gateway layer because traditionally, an API gateway is not purposely built for AML workloads, and you need more and more fine-grained authorization and security principles that you need to apply for AML workloads. So you need more robust practices for either AI keys that you might want to use in your platform, and also like when you are proxying request to the LLM service, again there are certain risks. So that basically made us evolve from an API gateway to an AI gateway. Which, of course, inherently it focuses on a lot of different other aspects that you already have in API gateways, but it adds more secure architecture for each and every layer as you described, from verifying client requests all the way getting a response back from your model service provider. Which means that you still have your traditional API gateway with you. But in addition, what we are also seeing is that whenever there's this workload, AI workload that you're running, you're also completely routing your traffic with proper fine-grained authorization so that only authorized users can actually make requests to the LLM and get a response. And then, of course, you'll also add some additional security aspects to this so that you can potentially have a hallucination detection so that if your LLM starts to have a mistake, then what are the insights that you can have. Then we'll also see some of the different security risks involved in LLM and how we mitigate those with the help of API. Now, there are various components that are specific for AI. Let me probably zoom. So the first thing is that we have some AI specific modules. So we need to ensure that whenever you are having an LLM model, you are properly whenever you are versioning the model, it's properly signed. You have ensured that there's something called as model scan that can scan your model itself for vulnerability. More and more of this will be covered by Ram. and then you also want to ensure that the prompts that have been given to the model, they are very secure. So you do a lot of A/B testing on a different types of prompts that are being sent to the LLM, and then you also can add some type of safety guardrails, which allows you to ensure that there's no bias inside of your model and there is proper toxicity filters that the LLM is probably does not say out something that's inappropriate. So you have some AI-specific models, and then of course for your AI gateway itself, in your API gateway, you're adding much more fine-grained authentication. You're adding rate limiting because, as you know, that LLM cost can vary skyrocket, and especially if you're self-hosting these AI models and you're using CPUs, you want to ensure that you have a proper because if you have, like, let's say, a microservice that might cost you thousands of dollars, but the same LLM, if someone goes ahead and probably conduct a DDoS attack where you maximize your number of with the revenue, it could be tens and thousands of dollars that might come cloud cost. And then having proper observability to basically track latency of the request that you're getting, error logging because LLMs are always at the risk of being able to hallucinate. So how much the LLMs are actually hallucinating for you, and having proper self-service APIs. So these are all the things that you need to basically take into consideration when you're designing your AI gateway. And yeah, basically these are the biggest threats that we have when running LLMs, right? So a lot of these things I've already covered, but things such as being able to get unauthorized access to your LLMs that you're using in production, or maybe some sort of a data leakage. You cover, how that might happen. From the supply chain security vulnerabilities that might get. We cover each one of them in more detail as we move forward. So that's why, the entire concept of zero trust security. How many of you have heard this term if you have worked with cloud native zero trust security? Why would you? So the entire idea here is that you want to apply zero trust security but for LLMs. And let's walk through the scenario. So the user starts to make a several requests and you have implemented application here. So you ensure that that particular user has proper access to service. You have based access control. If they don't have access, you simply deny them. If yes, then you go ahead and you would now issue them a certain secure access token. Now this would of course become a quick line for your machine learning use case. But here what we also do is that you also want to ensure that whenever you are using the application, it also has proper data governance and proper ethical model as well. So you always want to ensure that the model has been trained ethically as well. Otherwise, it might have bias and that can lead to a lot of issues, right? And once you have done a fairness evaluation, if it passes, then you great. We have our model being deployed into a secure runtime environment. So this is where you'll have added certain security layers on top. If you are deploying your model with the help of Docker or a container environment, so you can apply devices to have additional security, and then you do a proper input-output token validation. So this is more specifically for dealing with LLMs, where you want to ensure that your input token and output tokens are all being properly monitored for any prompt injection that might be taking place. Normally, let's say, we applied the entire zero trust security for our AI systems. And very similar to OAuth, where we usually talk about OAuth for security, OAuth basically came up with the top 10 LLM security considerations. So these are things that you should keep in mind when you are designing your own LLM system to ensure that you are having proper sensitive protection for data, prompt injection, you're handling all of these particular mitigations, and you're mitigating against all of these securities that you might have in your application. Let's just finally now talk about some of the key considerations for LLMs and how you can use purpose-built tooling for you to also handle all of these different areas. The first one is prompt injection. So this is probably one of the most commonly talked about points about LLM security because it's something that most companies are going to be vulnerable, and it ultimately depends on how strong your LLM has been A/B tested with the input prompts that you've added. So the entire idea for a prompt injection is that malicious actors will disguise themselves with somewhat being legitimate prompt, which tests your LLM to basically think that this is a legitimate request. And now that is basically being sensitive data being leaked to these unauthorized actors. So we can use different types of open source tooling like Repub, which essentially guides that how it does is that it provides you a bunch of different prompt templates that we can leverage, and this basically training the LLM to understand that okay, like, these could be these type of trick questions that or trick prompts that might use against that LLM. So it makes the LLM more aware of that it should answer and the one that it should not answer. Then you can also add some level of runtime security. So this is where you are proactively monitoring your API traffic for certain anomalies that you might be able to detect. And you can further enhance that security by ensuring that even the models themselves have been signed cryptographically. And you will see artifacts that are that are being pushed to that they are also secure. Of course, more to this by RAM and ensure that you use federated learning for more data. In addition to this, something that I've covered before, but also being able to add RBAC control on the user for trying to get access to your information. So what that means is that if you look at the traditional RAG use case, where you're getting information or you're fetching information from your LLM from that connects to your database. If you're adding proper RBAC control, then what happens is that when you're doing the fetching of the or basically racks, you have the retrievals step where you retrieve your data from a vector database. You can either do post filtering of the data or do pre-filtering. So based on the current uh, role-based access that is being given to the specific user, you can either pre-filter that data, so only the data that's accessible to this particular user, you only retrieve that data, or if you have done retrieval after your RAP step, you always filter out the data that's only accessible to that particular user. So this way you can have more fine-grained control over what data is being sent to the end user when they're using, let's say, a RAG. And you can also extend this to an AI agent session. That what are the set of tools that agents can invoke agents based on the role of that particular. And finally, like another important aspect here is personal identifiable information. So if your database has some private information about the user, you want to also ensure that the LLM never actually sends back some of this sensitive data as a response. So for this, you can use open source libraries like Llama Card, which apply runtime security to ensure that whatever response is being generated from the LLM, it does not have any personal information, or you can also anonymize such kind of data by using open source projects like Langchain. And this is, like the example last week, so finally what your user security would look like. And this is all we have also implemented in our own platform as well, using all open source technology. So for for guardrails, we allow users to basically set or to say these are the kind of keywords and response templates that the LLM should avoid at all costs. Then we have proper heuristics management. We are basically using an open source Llama model for also hallucination detection, which we have basically fine-tuned for our database. And then of course we have built our own in-house AI gateway that we are leveraging for managing routing all the requests that are sent. So I also have an open source example that I'd like to quickly show. So here I've basically created a Docker Compose file where I'm using COM. So of course COM, everyone might know that it's an open source API gateway, but they now also have provisioning for AI gateway. We are doing here from COM, we can also probably talk about COM. But the main idea that I'm basically doing here is that I have a bunch of services where I'm setting up the API gateway with COM, and then I'm also adding specific images that is specifically for plugin for managing my AI gateway. If I go to my terminal here, you'll see that I have a deployed LLM service. I'm not sure if I'm going to zoom in a bit more, but you can see here that I have this deployed LLM service, and I have I'm going to be basically routing an OpenAI call, and finally I have this proxy plugin. So the idea here, what it's going to be doing is that I have this curl request that you can see. So Here I'm making a simple API call to OpenAI. But what's happening is that one is happening as a proxy layer. So before my API request is being sent to OpenAI, Kong is basically intersecting that call and evaluating it, running some type of runtime security measures to ensure that the input prompts, all of those are correct. And it also gives me some metrics. So as soon as I run this call request, you can see that it tells me the total number of prompt tokens, completion tokens, all this information, valuable information about my call, and only then it basically routes that call to OpenAI. So this way, if you are basically like dealing with sensitive data, you can create your own AI gateway layer with proxies, looks out for the request for ensuring that there is proper security being maintained. So this way, like I've just deployed this particular service here for Kong. Of course, I mean, Kong is not just the only AI gateway, open source AI gateway that you can leverage today, but we are seeing that more and more companies that were working on API gateway are now transitioning towards support AI models, AI for, dedicated AI. So this way, like, you can leverage. And this is the final slide that I want to cover. So these are all the different open source tools that I've basically described that allow you to implement element security inside of an AI gateway. Like Llama Guard will help you to support PII information, also all the sensitive information that you might have. And then similarly, like if you are doing hallucination detection, so we have some Llama models that can help you with that. And then finally, one of the most important aspects, I think dive too deep into it because the next talk is all about how you can basically also do most secure AI models. So that's also something that Ram will cover, but that's also one of the most important aspects of everything from the future. You can create a very secure AI gateway, but in case your LLM itself has been tampered with, you will have unsecure LLM. Then that's CMO. So basically, this is a good segue for me to complete my talk. And of course, if there are any questions that you might have, feel free to ask me. But this was the final slide that I want to cover because we are in a CNCF meetup. So I wanted to cover some of the CNCF projects that help you to implement zero trust security with LLM apps. So we have OPA for policy is similarly powered now. And then if you're using like Cilium, SQA, kind of add on from that, those mesh services and add proper user experience or better security for your investment that you're making. Take a picture of this. And yeah, finally, here is your code for feedback. So if you feel that you learned something today, please, I highly request everyone to give feedback and we will also bring back to slide deck that I have to manage. But yeah, I'll conclude and if there are any questions that you want to have.